All right, so for today's installment of Mr. Rapsky Does Trig via video, we are going to find trig functions if I give you a point that is on a graph, okay? We're going to use that point to help us find the trig values. So first, as a refresher, remember sine is opposite over hypotenuse, so therefore cosecant is my hypotenuse over opposite. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. It's the inverse. And if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Okay, so the first thing that we're going to do is I'm going to give you a point, okay, on the terminal side. So we are going to graph the given point, and then we're going to connect it to the vertex of my angle, which is at the origin. Okay. Then we're going to sketch a triangle using that terminal side, initial side, and the vertex. We're going to identify our reference angle. Remember, the reference angle goes to the x-axis, because if I know the reference angle, I can use right triangles to help me find the legs of the triangle. And then we're going to construct a right triangle with the inclusive reference angle labeled theta. And we're going to label the leg lengths given by the point, or sorry, not leg lengths, that sounds silly, side lengths, but they are legs given by the point. So these are going to be the legs of the right triangle. And then we're going to use the Pythagorean theorem to help me find the missing side. Remember, that's a squared plus b squared equals c squared. And then we're going to use SOHCAHTOA to help us set up the ratios. Okay, so we got a lot going on. And if I could spell TOA, that'd be great. TOA. All right. So first step, example number 1. Find all 6 trig functions given the terminal side goes through the point -5, 12. So -5, 12. Here we are way up here. Okay, so my initial side goes this direction, and then I'm going to have my ray. I'm going to cheat. I'm going to use a ruler here so I can make sure that I have a straight line to that point, to the origin. Okay, so this angle right here, that's the angle that is in standard position. What I need to do is I'm going to drop a side down, and I am going to create a side over here, and we're going to use this reference angle as theta. Okay, so that's the angle we're going to use inside the triangle, because we're always going to the x-axis and we're in quadrant 2. So remember, if -5, +12, I went left 5 units, so this side is -5, and I went up 12 units, so this side is +12. Okay, once we have that labeled, we're going to use the Pythagorean theorem to help me find my hypotenuse. So we're going to take 12 squared plus -5 squared, and that's going to give me my hypotenuse squared. So it's 144 plus 25 is equal to h squared, and that is 169 is equal to h squared, which means h is equal to, when I take the square root, 13. So this length right here is 13. Okay. The other thing we need to remember is all students take calculus. So that, remember, means in this quadrant, sine and cosecant are going to be your positive functions. Everything else is going to be negative. All right? So that means if I'm talking about sine is going to be positive, cosecant is going to be positive, and cosine, secant, tangent, and cotangent are all going to be negative functions. And you'll see how this plays out. Okay? So the sine of the angle, sine is opposite over adjacent. So here's my angle, opposite is across, that's 12, over hypotenuse, which was 13. Cosecant is the reverse of that, so flip it. Cosine is adjacent over hypotenuse. So next to it is -5 and across from it, or hypotenuse, is 13. So there's my negative. It's -5 over 13. When I flip it, I get 13 over -5, or the whole thing is negative. Tangent is opposite over adjacent. So now I'm going opposite, which was 12, and adjacent is -5. So we're at 12 over my -5, which makes the whole thing negative. And then I'm going to flip it for cotangent, where it's adjacent over opposite. Okay? And we just found all 6 trig functions. So that's a lot easier than when we did it trying to find the exact value. If I know it goes through a point, I can easily determine those 6 values just by using the Pythagorean theorem. Okay, so let's look at another example just so we make sure we got it. So -2, -3. So we're at -2, -3. Okay, so from my origin, I'm going to draw in a triangle. My reference angle is the angle that comes from, here we go, it comes from the terminal side to the x-axis. Okay, so this is the point -2, -3, which means that this is -2 and this is -3. I went left 2 and down 3. Okay, let's use the Pythagorean theorem to find my hypotenuse. Hypotenuse is always positive. Doesn't matter what quadrant you're in. But what you're going to find is sometimes it's not always a perfect value. So we are actually going to use the square root of 13 and it doesn't reduce. So I have the square root of 13 is my hypotenuse. Okay. All students take calculus. So all students take calculus. Since we're in this quadrant and we're in T, that's tangent and cotangent are your positive ones. It means all other functions are going to be negative. So these two are going to be positive, and we're going to have negative, 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 negative. Okay, and you'll see how that plays out when you work with your ratios. So sine of the angle is opposite over hypotenuse. So from the angle opposite, here's adjacent, and here's your hypotenuse. So opposite is -3 over the square root of 13. Now remember, you cannot leave a radical in the denominator. So we're going to rationalize as square root of 13 over the square root of 13, which gives us 3 root 13 over 13. And 3/13 doesn't reduce, so we're good with that. Oh, but it was negative, so don't forget that it was negative. Cosecant is the inverse. Inverse the original. So the inverse, instead of opposite over hypotenuse, we're going to do hypotenuse over opposite. So root 13 over 3. This one you don't need to rationalize because you don't have a radical in the denominator. Okay. Cosine is adjacent over hypotenuse. So now we're taking -2 over the square root of 13. And again, you're going to have to rationalize. So we're going to multiply by the square root of 13 over the square root of 13. We get -2 root 13 over 13, which does not reduce. 2 and 13 have no common factors. And then reciprocate. So then we're going to have the square root of 13 over 2, and that's negative. Tangent, opposite over adjacent. So now we have a -3 divided by a -2. That's where we get our positive. So even though I have a negative over a negative over a negative is a positive. So we get 3 over 2. And reciprocate that, we get 2/3 for cotangent. Okay? All right. So that actually is kind of where part 1 ends, because the 7.3b we're going to do the steps for, well, you know what? Let's actually go ahead and do them, and then in 7.3b, we'll just review. Okay? So the first thing you need to do is identify the quadrant in which the terminal side lies. Oops, my Q didn't work. Okay, then we're going to sketch a triangle in the appropriate quadrant. We're going to label the reference angle with theta. We're going to use the given side lengths to label the sides of the triangle. Then you're going to go ahead and use that Pythagorean theorem. And then we're going to use SOHCAHTOA to find the other ratios. So for this scenario, we give you one of the trig functions. So I give you something like sine is this, or cosine is this. And then I want you to find the other 5. So take a look at example number 1. So I'm telling you that sine is 4/5. Sine theta equals 4/5. Well, what do we know about sine? We know that sine is the SO. That means that sine is equal to the opposite over the hypotenuse, which means that 4 is the opposite and 5 is the hypotenuse of the triangle. Okay, so I'm giving you those side lengths. Also, theta is between 90 and 180. So if this is 90 degrees here and this is 180 degrees here, that means that the opposite and the hypotenuse are somewhere in this 90 and 180 range, so we're in quadrant 2. Okay, so the first thing we know is our triangle needs to be here in quadrant 2. Okay, sine is 4/5, so the hypotenuse is 5. The opposite, so if my angle comes from the origin, opposite ends up being the vertical. It's the y value. So my y value is going to be a height of 4. And I know that I'm going to have, and this is a little hard, I normally don't do this in the quadrant or the coordinate plane. So this value is 5. I know that I have a height of 4. The question is, what is the x value? Now, I may have actually graphed this a little bit incorrectly, but we're just making a sketch. So let's find that x value. Let's find that side length. So I know that it's x squared plus 4 squared is equal to 5 squared. So x squared plus 16 is equal to 25. Oops, not degrees, just 25. So if I subtract and subtract, I get x squared equals 9, which means x equals 3. So this value is 3. So it's not technically plotted in this correct way, but it was a sketch. So the theta is always inside the triangle to the x-axis. So if I know sine of theta is 4/5, well, that's given. Okay. In quadrant 2, this is all students take calculus. So here we are, students. So sine is positive. The x value actually is a -3, and I need to do a better job of that because we're in quadrant 2. And in quadrant 2, x is negative and y is positive. And we've moved to the left. So there's a couple of things that we're trying to figure out in that one. Cosecant is the reciprocal, so I can just say 5/4. Cosine is adjacent over hypotenuse. So that's -3 over +5. And remember, cosine in this quadrant, sine and its friend, cosecant, those are your positive ones. Everybody else is negative. So then this would be -5/3, reciprocate it. And then for tangent, opposite over adjacent, 4/-3. And reciprocate it, -3/+4 for cotangent. Okay. So I didn't do a very good job explaining that one, so I'm going to do a better job on the next one, and I'm going to not maybe use the coordinate plane, because I think the coordinate plane actually makes things more complicated. So, given cosine, so I'm telling you about cosine, is 5 over 13. The cosine is the adjacent over the hypotenuse, okay? The terminal side is in quadrant 4. Okay, so I'm telling you we're in quadrant 4, so we're over here. All students take calculus. That means that cosine is positive and its friend secant is positive. All right, so if I draw a triangle, and I'm going to do it over here instead. Here's my theta, and it can be anywhere, but, and well, not where the 90 is, but so there's my theta. I know the adjacent is 5 and the hypotenuse is 13, which means that I'm trying to find x. Okay, so 5 over 13, let's do 5 squared plus x squared equals 13 squared. So it's 25 plus x squared equals 169. And I have x squared, if I subtract the 25, I get x squared is 144, and if I take the square root, x equals 12. So this value is a positive, or is 12. Now, since I am in this quadrant 4, now I'm going to go ahead and do a better job. I know that from the angle needs to be here to the x-axis. So I know that the adjacent had to be 5. So I'm going to go positive 5. And the opposite from there was 12. Oh, I actually don't have enough room. Well, it's down here. And so the angle is here. So if I'm down, this is negative 12, and this is a positive 13. Okay, so I'm taking this triangle and I'm kind of flipping it around. Honestly, if you just remember this part, this cosine is positive and secant is positive and everything else is negative, it really doesn't matter if we use the coordinate grid. Okay, so I'm going to go ahead and label that. This is positive, sine, cosecant, tangent, and cotangent are all negative. Sine theta is opposite over hypotenuse. I'm going to go back to this triangle. Opposite and hypotenuse. So I'm doing 12 over 13, and since it's not in, or it's in quadrant 4, those are negative. 12 over 13. Reciprocate it. Cosine. Cosine I was given was 5 over 13. So secant is 13 over 5. Tangent, let's go back over here, is opposite over adjacent. So opposite is 12, adjacent is 5. So I have 12 over 5. And it's supposed to be negative because I'm in quadrant 4 and only cosine and secant are positive. And then reciprocate it for the inverse function. Okay? A lot of examples because I think sometimes it's just really confusing. So we're going to take a look at this one. Okay, between 90 and 180. So here's 90, here's 180. That puts us in quadrant 2. All students take calculus. So students is sine and cosecant. Those are your positive. Okay, so the sine is going to be positive. Your cosecant is going to be positive. Your cosine is given as negative 3/5. Your secant means that we can reciprocate that. We can get that one right away. Your tangent is going to be negative, and your cotangent is going to be negative. Okay? So if we draw in our triangle, and let's put theta here this time, and I get adjacent over hypotenuse. So I'm going to make this a positive 5 and this a negative 3. Means I want this x I talked about in the first lesson Pythagorean triples, where if you had a 3 and a 5, that means that x has to be 4. Now you can verify with the Pythagorean theorem if you do negative 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 equals 25. That is true. So that means that this value is a 4. Okay? So if I look at sine, sine is opposite over hypotenuse. So here's your opposite, here's your hypotenuse. So therefore sine is 4/5. And it's positive. Oops, one purple. 4/5. And then reciprocate it to get your cosecant. Tangent is opposite over adjacent. So if the angle is right here, then here is your A. So 4 over negative 3, because remember I told you it was a negative, and then reciprocate it. Okay, see how it starts to get a little bit easier? Honestly, labeling from the quadrants is going to be the best way to go. Okay? All right, let's just do it. So now I'm telling you that sine of theta is negative root 2 over 2. So again, sine opposite over hypotenuse. Okay, 180 to 270. Well, here's 180 degrees. Here's 270 degrees. So we're in quadrant 3. All students take calculus. T, that's tangent, and cotangent are positive. Okay, so if I start with my sine, my cosine, nope, well, yeah, let's just do it here. Let's just do cosecant here. Secant, tangent, and cotangent. Tangent and cotangent are positive. Everything else is negative. We're given that sine is negative root 2 over 2. Reciprocate it. So that's 2 over root 2. Don't worry about signs. We already did the signs. Remember, I can't have a radical. So then this is negative 2 root 2 over 2. Now that actually reduces. So we get negative square root of 2. Okay, so that is my cosecant. Cosine. We don't have cosine, so we need to draw our triangle. So I draw in my triangle. Doesn't matter how it looks. Right angle. Need a theta. Sine is opposite over hypotenuse. So label your opposite as negative root 2 and your hypotenuse as 2. Use your Pythagorean theorem. Negative root 2 squared plus x squared equals 2 squared. If you square this, we get 2 plus x squared equals 4. So if I subtract 2, and I get x squared equals 2, so I take the square root, so I get the square root of 2 for the missing side. Okay? So if I'm going to do my cosine, that's adjacent. So that's the square root 2 over 2. But it's negative, which actually, remember, look at it, it's the same as the sine. So that means my secant and my cosecant are going to be the same. And I'm going to just say the square root of 2. I'm just going to skip right to that part. Because I know when I reciprocate this one, I get negative root 2. So if I reciprocate the same thing, you're going to get the same thing. Okay? And then tangent is opposite over adjacent. So here's your opposite, here's your adjacent. So I take the negative root 2 over root, the negative over root 2, and then this technically is positive, but tangent is supposed to be positive with the end, so I'm guessing because we're in quadrant 4, or quadrant 3, yeah, everything is negative. Oops, I'm running low. I'm almost done, guys. So I am just going to take root 2 over root 2, and that's just going to give me positive 1. And if I reciprocate positive 1, I also get positive 1. So cotangent is positive 1, tangent is positive 1, cosine is negative root 2 over 2, and sine is root 2 over 2. Alright, sorry guys, that was a longer one for this unit, but I wanted to make sure you got plenty of examples. Alright, happy trig.